So in today's video, we're going to be going over part 2 of the methods, list methods. Now you can go ahead and check out part 1 in the link in the description, but for part 2, we'll go ahead and jump into .index, the in keyword, .count, .sort, sorted, which is a function. Now these two will probably throw you off, but they do roughly the same thing. And then we'll go move on to .copy as well as reverse. So let's just jump right in. We'll start with the index. So what I've already established for us is a my list, which is a list, and it's holding string values as well as integers and a Boolean value. Now, if we're going to go ahead and use index, we can call the print function. So we're going to go ahead and print my list, and then we'll do .index. Now, when it comes to the index, you can either call an object as well as a start position and a stop position, but we'll just start with the object. Now, an object essentially is a value. So let's say we want to see the value of A. If we're to go ahead and print that, we would get 0. Now notice we've actually got 2 A's right here. When it comes to lists, you always start at 0, and then you count up 0, 1, 2, 3, and so on. Now, the reason that we have 0 shown rather than many values, or rather than starting at 1, is because A begins at the position of 0. Now, if hypothetically we were to go ahead and say, let's start at position of 1, and let's go ahead and stop at the position of 3, what would happen then is A would be shown in position 1 because we start at position 1 and we go up 2, but not including 3. So 0, 1, 2, 3. So we go between 1 and 2, position 1 and 2, and A is in position 1. So that's why we're getting the position of 1 rather than starting at the position of 0, which is what we would have done had we not actually added a start and a stop position. Next, we'll go ahead and move on to the in keyword. Now within Python, there's a lot of keywords, and I'll link a website in the description for you to learn more about the different keywords within Python. But for those of you familiar with it, you have the in keyword, del keyword, even for keyword, and those are just a few to at least name a few. Now, when it comes to using the in keyword, what we would do is we would go ahead and say, hey, let's see if A is actually in my list. If we were to print that, we would return true. Now, the reason we return true is because A is actually within my list. If, for example, we were to change A from A to, let's go with a Z, which is not in the list, we would get a false value. The same is true for integers, 1 in my list, and the same is true for the Boolean value of true. So we'd also have true returned. Now, let's hypothetically say we wanted to also be able to say, is there a D in the following string? This is an awesome view from on top of the world. So if we were to say, is there a D within this string, we would get a true value. This is because D is shown in the string itself. Now, you can also do the same for integers, and likewise, as I've already shown, with Boolean values. And you could even use this for dictionaries and tuples and sets and so on. So the in keyword will go ahead and show you if a value was in the string or whatever the variable might be that we want to see if the keyword is in. So next, we'll go ahead and move on to the .count method. Now, when it comes to the .count method, it will go ahead and count for us the number of values within the list. So for example, let's do a print my list, and we'll do .count, and let's go ahead and see if there's any H's within my list. If we were to print that, we would get 0. That's because there are no H's within my list. But if we were to do A, what would return is we'd get 2 because it counts how many of the value are within the list itself. So the .count method will actually be very useful when looking for true or false values, ones or zeros, and it's useful in data science when you want to find a target if you're able to find that within the list that you're seeking, or even possibly a dictionary or something of the sort. Next, we'll go ahead and move on to the sort method as well as the sorted function. Now, these two actually threw me off a bit when I was first working with learning Python, I should say. But what sorts will do is if we were to go ahead and print this, notice we also still have the Boolean value, the integer, and the string values. What would happen is we get an error. Now, the reason that we get an error is because you cannot sort the string, nor the integer, nor the Boolean value. Sort will go ahead and work with just string or just integer, or likewise just Boolean values. Now, if we were to go ahead and get rid of the integers and Boolean, and let's go ahead and add, how about a Z? And, whoops, go ahead and add Z, and let's change this A to, how about an F? If we were to go ahead and now use the .sort method, what happens is we would return none if we were to go ahead and print that. But if we were to go ahead and print my list, what we would get is we get the list returned to us sorted. Now, the reason that we're getting a none value right here, like no value, is what's happening with the .sort method is it's essentially sorting the list itself. It's not actually kind of returning any value for us to go ahead and print out. So that's why we're getting none. All this does is it sorts it. And then once it's sorted, it is then permanently sorted in memory. So then my list will remain sorted all the way throughout your algorithm from then on. That's why you're not getting an actual value returned. But if, for example, let's go ahead and separate these real quick. So we're going to separate this for the next example. If, for example, we were to go ahead and use the sorted function with my list, what would happen is within the sorted function is we would get the list sorted right away. So when working with the algorithms, if you want your list to go ahead and be sorted and remain sorted, then you would use .sort. However, if you just wanted to go ahead and print out a sorted, your list in a sorted way, then you would use the sorted function. So just remember, this will be permanent and this is just temporary. And that's how I was actually able to remember it. Hopefully that makes a little bit of sense to you guys. And now kind of moving on, we'll move on to the .copy method as well as the brackets. Now, what I've already established for us is I've established a new variable, which we'll call mylist, or new list, and we'll set it equals to mylist.copy. Now, if you haven't guessed already, the .copy method will provide a copy of the list that we want to go ahead and copy. So, for example, if we were to go ahead and print my list, and if we were to go ahead and print new list, what we would have returned is obviously the same list because we're using a copy with the .copy method. Now, if hypothetically you wanted to add values to the new list and not to my list, so not here, but you want to add values here, you could do a new list .append. Remember, append will go ahead and add a value to the list itself. So we want to add A. So if we go ahead and print the new list on the bottom, we would get the A appended to the copy of my list, but not appended to the beginning or to the original my list. And now the same is also true of using brackets, similar as slicing. Now, the reason that this is considered a copy is because you start at 0 and you go up to the end of the list itself. And that's why I kind of just left both these blank. So you go start the first position and you go all the way to the end. And now likewise, if we were to go ahead and print this one as well, but let's change this to like a Z. If we were to print this, what happens is rather than an A right here, we'd have Z printed out because we wanted to append Z. But the point is that we created a copy with these brackets. So just remember that you can create a copy of a list by establishing a new variable and then setting it equal to the original list. Likewise, if you wanted to, you wouldn't actually need to use a variable, but you could always establish a new copy by doing mylist.copy, and you can go ahead and print out the copy of the list. And then let's get rid of the new list. So if we go ahead and print that, we'd have what's essentially happening is we're having the copy of the list printed out. Now remember when we tried to print out the .sort method, we had a no value returned, but with .copy we will have a value returned because it's the copy of my list. So hopefully that makes sense as well. And then finally, we'll go ahead and move on to the .reverse method. And what do you guys think that will go ahead and do? So if you kind of haven't guessed already, so if we use reverse, what happens is we get no value. But if we were to go ahead and print my list, is we would have the reverse order printed out. It doesn't actually sort it and then reverse it, but rather it just returns the reverse of whatever the list already is. So up here we're starting at Z, and that our output is Z is at the end of the output. Now, if, for example, you wanted to have like everything printed in reverse order and have it sorted, what you could do is remember we can use the .sort method because that will make it permanent. So if we were to go ahead and use mylist.sort, and if we were to go ahead and call the reverse value of this, so again, we're sorting it, and then we're going reverse, and then we're going to go ahead and print it out. We'll have ZFCBA. So what was sorted essentially was it was sorted in proper order, so A, B, C, F, Z, and then we reversed it. So just know that if you do not return a value, or if you have like none printed out, that what's happening is the list itself is actually being readjusted. And then what we're going to go ahead and print out later is you just need to call the variable or the list itself to go ahead and have the output of whatever you wanted updated. So kind of in review, you have the .index that'll go ahead and provide the position that the value is in within the list. So again, 0, 1, 2, 3, and so on. It'll return whatever position the value is within the list. The in keyword will go ahead and return if the value is within the list itself as a true or a false output. Finally, .count will go ahead and count the number of occurrences within the list itself. Again, good for data science. .sort will go ahead and sort the list itself, but remember it will be permanent. So always try to make a copy. Actually, those two would work well in tandem. Use a .copy and then .sort. Sorted, the function, will go ahead and just sort it temporarily, and it will print out whatever the sorted list is. And then both of these two will provide a copy of your variable itself. And then finally, what we just went over, reverse. Remember, it'll reverse this as it is, but not in a sorted fashion. So hopefully that makes sense. I'll go ahead and add some practice examples to this video. If you like, please feel free to check out some of my other videos where I do go over Python programming. And please feel free to check out the links in the description to learn more about list methods and to get a little bit of practice with these list methods that I went over in the video. But otherwise, I want to thank you guys for watching this, and I'll see you in the next video. Thanks, guys.